Hi Year 8 Science students. This is lesson 5 on sedimentary rocks. So we're just doing the life cycle, we're breaking it down. So we did igneous rocks, and sedimentary rocks are next. So we're going to look at, that was a picture of the Grand Canyon just before, so that's something that we're going to look at and analyze. So warm-up questions, describe the following term. What is a magma, A, and what is B? Intrusive igneous rocks. Okay, so the answers are magma is molten rock that does not reach the Earth's surface. Intrusive igneous rocks are igneous rocks that form below the surface of the Earth. Remember, internal, intrusive. Just remember how I explained that in the last lesson. Just going over that because we definitely need to know the difference between intrusive igneous rocks and extrusive igneous rocks. Okay, so this lesson, lesson 5, sedimentary rocks. A good place to see sedimentary rocks is the Grand Canyon in the United States, and that's what that image was at the first page. It displays some of the deepest layers of sedimentary rock on Earth. So the lesson intent is to examine and describe formation processes and types of sedimentary rocks. Now the spelling words is biogenic sedimentary rock, cement, chemical sedimentary rock, calcic sedimentary rocks, fossil sedimentary rocks, and strata. Now, to be successful, you need to be able to identify different types of sedimentary rocks, describe the processes involved in their formation. So the learning sequence today is going to be revise the process of weathering and erosion, define sedimentary rocks, and explore and model the formation of sedimentary rocks and identify types and structures of sedimentary rocks. So just as you know, there's going to be bloopers through this thing. There's going to be purposeful bloopers. So I'll let you know. Sedimentary rocks made from sediments, small particles of weathered rock or crystals that have been left behind when the solution has evaporated. So to form a sedimentary rock, the sediments need to be compacted and cemented. It occurs during the burial as overlaying sediment compacts, and the compaction of the sediments force out excess water. So you've got layers upon layers, and it just squashes it down and it cements it all together. The groundwater naturally contains chemicals such as silica and lime, which cement or stick the sediments together, forming a larger rock. So there's 3 types of sedimentary rocks. There's calcic, chemical, and biogenic. So calcic sedimentary rocks are formed when sediments are laid down by wind, water, gravity, and ice, and then compacted and cemented together. So you have erosion and type of thing. They basically look like there's 4 characteristics. So the characteristics are they contain broken pieces of other rocks, and this is called a clast. And that's in your homework. Clast is in your homework. You have to be able to identify what a clast is. It's actually parts of broken rocks, the really small, the weathered material that you've had. May have layers stacked like up a book, like a sediment building, and it deposited, so it's sort of like layered up. It has grains that not interlink and they do not crystallize because they were cemented together. So say for instance, you get a pile of pebbles that are broken up into little tiny pieces, and then you just pour cement through it, you're going to get that pebbly look with space. And also they may contain fossils. So here are some characteristics summarized in the image. It's just layering down, it's compacted down together, the cement just weaves in between, and there's no direct interlocked, but it's all like kept together like cemented pebbles. So that's what it looks like. Clastic sedimentary rocks are classified mainly according to their size and nature of the rock grains and the chemical composition of the cement. So conglomerate is just large rounded rocks cemented between grains that are often microscopic. So here you see in that one, it just looks like it's a building of different rocks cemented all together, mishmash. Then you get a mudstone, which is particles often microscopic and very, very soft rock. Breccia, similar to conglomerate, but lumps are sharp edged. So it's got a very distinct edge to it, like it's been broken off. Sandstone is particles of sand, usually harder than mudstone. Okay, so there's the 4 different types of sedimentary rocks. Clastic sedimentary rocks. So now we're going to look at chemical sedimentary rocks. Now these form when minerals dissolve in underground water. They crystallize within the sediment, and when the water evaporates, they leave behind the crystals. They're usually soft and they sort of very brittle and easy to break, most of them. So gypsum is very fragile and halite. Limestone is different though, it is a bit harder. So, but it has got that, that very gentle look about it, but it actually does erode pretty quickly. All right, biogenic sedimentary rocks form when dead plant matter or animal remains accumulate or build up and are then cemented together. Small amounts of sediment from weathered rock added to the organism. So over time, you get your plant material that lays down, and or you get that big build up. They get a layer of that plant material. Then more rocks and more activity happens, and it overlays it. That it's compression over layers of time, and as in the diagram, it's showing that real intense compression and pressure that's built up, and then it compacts it, and that's how coal, one of the examples are coal and how that is formed. So that's why we get different types of coal, because it depends on how much pressure it's been under, how much chemical change it has gone through. So you get thermal and coking coal, which in Billwheeler it's thermal coal, which is used to generate power. And in Mara, it's metallurgical coal, which is used to make metal and melt metal. So there's the different types of coals. The characteristics is it's layered, it's soft, and sometimes there's exceptions to the softness of it. Shells and flint are fairly hard, so they're exceptions to biogenic sedimentary. Sedimentary rock and geological history. So we can actually tell the age of rocks according to the sedimentary rock in the layer. So and it's called a strata. So they can be horizontal with younger sediments on the top and older sediments down the bottom. Hence, if it's undisturbed, the sequence can then give you the indication of the age of that layer. And also there's another way a relative age of rock strata can be compared using index fossils. So an index fossils, to be an index fossils, there's three things it has to have. The fossil needs to be found over a widespread area, so they need to be on different continents. The fossil has to be lived in a narrow period of time, so you've got a distinct lifespan on, you know, what years that fossil was around. And the fossil has to be abundant and has to have a lot of them of that organism living at that time, so that there's the high chance of you finding them at that time. So if you find the same fossil in two different locations, and you know that that fossil occurred at this time of this era, you definitely then can be sure that those rocks, despite where they're in two different locations, are definitely the same age. So it's really important for geological research that they age rocks appropriately. Now, the formation of fossils. Fossils are preserved evidence of organisms that once existed on Earth. The whole body or part or traces of an organism's activities, like the burrows or tracks or even dung, can be turned into rock, and it's called coprolite. Note, difficult to preserve soft parts as they decay faster, so therefore you won't see many mollusks and you won't see many soft-tissued animals or invertebrates preserved. It's usually the hard parts like the skeleton, or the shells, or the teeth, or the wood that is preserved. If the body is covered with sediment, and then weathering and decay will be slow. So it's kind of like a seal. So that's one way of doing it. But even better, if it's got no oxygen, so say for instance, it's preserved at the bottom of the ocean, lake or river, that even slows down decay even further because oxygen accelerates it and you get lots more growth of it to be decayed. So there's the formations, and there's some diagrams of different fossils. So there's a plant leaf, a flying reptile, and a emmamite. Having a terrible day with words today. So homework. I'm very conscious of the fact that we're going to be coming back to doing the exam. So I want you to get used to some questions. So we're going to go back to the textbook. We're going to look at module 8.3 review questions on page 349 of the Pearson Year 8 Science textbook. We want to practice for the exam, so get used to it. Try and do what you can. If you can't finish all of it, that's fine. Now you're going to add to your journal on what class you have of sedimentary rocks in your rock collection, either on your own personal one, or if you don't have rocks, you can go and look at the collaboration page and try and identify the ones that are on the collaboration page. Here is the rock journal. So this is the key that you could use. Now we've already given you one for igneous igneous rocks. Now I'm giving it to you sedimentary rocks. So we're going to look basically cementing that sediment together. Having a look at what type that is and going through and using the key like you did in the other ones. Now, just so that you know, blooper alert, I'm not going to give you any hints, but if you're very much watching, you should know. I'm about to do a song, and let's see if you can know what it is. It's a very old song, so some of you may go, oh, that's really prehistoric. Mrs. Conway's very old. Okay. So it's got to have something to do with our theme of what we're learning, and you have to think of the name of the song and who sung it, and see if you can tell me what is the main part in the chorus. All right, watch all the YouTube videos. All right, that's it for today. Thank you very much, guys.